Hello, this is Schedulytics and welcome to today's session. In today's brief video, we are going to look at chi-square goodness of fit test, its application in one form where we are going to see how we can test whether the observed proportion of a categorical variable is different from a hypothesized set of proportions. So first of all, you have to identify the category of your categorical variable. For example, in this case, marital status, let's see how many categories it has. So it has 3 categories. And so when you are testing the proportions, you should list 4 proportions. And let's say sex, there are 2 categories. So we are going to just list 2 proportions. And let's say nephropathy, tap nephropathy. So you realize we have just 2 categories in this one too. So now for you to be able to run a chi-square goodness of fit test to test whether a proportion of a categorical variable differs from a hypothesized set of proportions, you need to first install it. So to do that, you click or you type find it csgof. That is chi-square goodness of fit. So you just press on enter, and then you have this menu for you to be able to install what you are looking at. So when you click on this, it will open a section for you to install that package. I've already installed that package, and so I will not be needing to do that. But in your case, you click on it to install. And then after that, we can continue with what we are discussing in that video. So now let's go back to STATA platform and see how we can be able to navigate our way around that. So now, for you to be able to test that proportion, you press csgof, and then your categorical variable. So let's say nephropathy, and then we type expected proportions, and then into brackets, we are going to type our proportions that we expect them to be. So we are expecting that nephropathy absence will be 86% and present will be 14%. This is a hypothesized proportion that we have learned from literature based on where we took our sample from, that the prevalence of nephropathy among those set of people is 14%. And so if that is the case, we want to see if what we are having in our data set now, in our sample, reflects that or it is different. And so we use the chi-square goodness of fit to run that. Now we click on enter, and then here the statistical significant level by the p-value tells us that this is not statistically significant. And so we would fail to reject the null hypothesis that states that the proportions are similar. And we can say from our observed frequencies, the observed frequencies are what? This and this. And when we express this in proportion wise, this is close to 85.59 thereabouts. And this is 13 something 51 or 49 thereabout. So it is also close to these values. And so we can say proportion wise, these observed proportions is similar to these expected proportions. That is why our significant level is not statistically significant. Now, there's one thing we need to know in doing that. Now, proportions add up to 100. So assuming that we made a mistake by saying this is 11, and then we press enter, see that it gives us an error. It says expected percentage do not total to 100%. The sum of 86 plus 11 is 97. Please simply supply percentages that add up to 100. So it's very important that when you are using the chi-square goodness of fit, your proportions in the box or in the brackets should add up to 100. Now let's use this same for a different category. marital status, where we establish that there are 4 categories. And so here we are going to, let's say 50, 20, 20, 10, 10. This plus this is what, 20. Okay, so let's make this 30. So this plus this is 80 plus 10, 90, 100. All right, now let's click on that. Good. So here it tells us this is statistically significant because the p-value is less than 0.05. It's 0 here, 0.00. So what it means is that our observed frequencies are completely different from what we are expecting. So in this regard, they are different. So basically, this is how you can leverage or use the chi-square goodness of it to test whether the proportions of your categorical variable differ from what you expect. If you find content such as this useful, we encourage you to subscribe to the channel. We encourage you to like and share. Until we meet again on our next one, this is Catalytics, and it's a bye.